All right, here we go. Find the sine of theta and cosine of theta of the given angles or points rather. And so here we go. And I think that if you actually just try this on your own, you'll be able to figure it out. Kind of as a hint, draw in your triangle into the given point. But knowing that, take a moment, go through, see if you can figure this out without the video, and then come on back and check it after you're done. Okay, so I hope you have tried this out. And so here we go. The y value, just because we happen to be here at y, is -3. And so I'm going to put -3 here. And now, even though the distance of this side is positive, and so really it should be a +3 side length, I'm going to leave the negative because I think it helps illustrate the point. At the same point, the -4 is our x value. And again, distance is always positive, but I'm going to leave the -4 because I do think it helps illustrate the point a little bit better. So to find the sine of theta and the cosine of theta of our given theta, that angle right there, of our central angle, we need to know what the hypotenuse is. And so it's a 3, 4, 5 right triangle. This is going to be a radius of 5. And in case you're not remembering how to do that, that's going to be a squared plus b squared equals c squared. So -3, it's supposed to be a 3, -3 squared plus -4 squared gives us c squared. That's 9 plus 16, which is 25. So c equals 5. And again, it's going to be a +5 because distance is always positive. So these, one more time, these should be +3 and +4, but I'm leaving that negative on there just to kind of illustrate the point a little bit. Now here we are. What is our sine and cosine? So let me clear this space up again. So sine of theta, or sine is opposite over hypotenuse or over radius. And so our opposite side here from this angle is going to be our -3 over our hypotenuse of 5. And we end up with a sine of -3/5. There's the sine of theta. Now cosine of that same angle, so cosine of theta. Cosine is adjacent over hypotenuse or over radius. And so we have the adjacent side is the -4 over the hypotenuse of 5. So we have -4/5 as cosine. And those both are negative because remember in the third quadrant, only tangent is going to be positive because we'd have a tangent. And even though we haven't gone over this, let's go ahead and show you. Tangent of theta would be opposite over adjacent. And so we would end up with -3 over -4, giving us +3/4. Because remember, tangent is positive in the third quadrant, and there's y. All right. And in case you haven't paused and tried these on your own, please really do pause now and try this one before walking you through it. Okay, so I hope you have, in fact, tried it. And so here's our triangle. Let's go ahead and sketch that in. And theta here is, we don't know what theta is quite yet. Looks like it's a negative theta value because it went down clockwise. Although that really won't change our problem that much because we're just looking at, well, here's our triangle and what pieces do we know. So our x value, +12. Our y value, -5. And again, that's a distance-wise, that's a +5, but I think the negative helps illustrate the point. And so what's our hypotenuse? Well, 12 squared plus -5 squared gives us that hypotenuse squared. 144 plus 25 equals the hypotenuse squared, and we get 169 equals h squared, so our hypotenuse is 13, which makes sense. There's a 5, 12, 13 right triangle, and there we now have found it. Okay, what is our cosine of theta, or sine of theta and cosine of theta? So sine of theta is opposite over hypotenuse, or over radius. So we've got -5 over 13. So sine of theta is -5/13. Now cosine of theta, And you might be thinking, hey, this is in quadrant 4, cosine is going to be positive, and you're right. And so we got adjacent is 12 over hypotenuse, which is 13, positive 12/13. You could also find the tangent of theta. So tangent of theta is going to be your opposite over adjacent, which would be negative 5 over 12, so negative 5/12. All right, I hope that helps.